Welcome. I am calling this class Russell II Background Part 2, Sheet and Rill Erosion Assessment, Core Terms and Concepts. And we'll start off here with an introduction and plan of action. Most of you probably have joined us before, but I'm Chris Lawrence. This is me down here. I'm your speaker, responsible for all the mistakes. Lydia Fitzgerald is our new partnership conservation agronomist, Virginia Tech employed, embedded with NRCS, grant funded. It's been incredibly helpful in many ways, and especially in moderating and managing these Zoom sessions. So thank you, Lydia, for your help. One of the things that I've done is try to interject or insert these interactive review questions. So look, here's the idea, guys. You should know the answer to this question. Even if you don't, here's the point. Try to get you guys engaged a little bit. And the Virginia NRCS Erosion Resources Index, it is your guide to many of the documents that I've been talking about in this webinar series, and there'll be another document or two that I'll talk about today. A great way to access all of our erosion resources on the FOTG is to go to this Erosion Resources Index, which has quick links and descriptions of each document. And how do you find it? Well, that's the question. And hopefully you guys are remembering, right? This is, and I'm getting 95% of you answering the question correctly. So let's just be clear here. Forgive me, my pen is not working well. Okay, yes, A is correct. Go to the FOTG for Virginia, then go navigate to section 1, erosion information. The document is right there. Click on it and you'll open a PDF. There are other options, but the above is easiest to remember. So the answer is C, all of the above are true. Okay, hopefully I'll do a better job. The next poll question will go more smoothly. There'll be another interactive review question to get your juices flowing here, get your minds working before we begin new material. This is a review question to cover something that we discussed on the last webinar, okay? This is a more complex question. So I want you to start reading and thinking about what is the best answer here. And when you have come up with one, please vote on your best answer using the poll. I appreciate you guys working through this. This concept, I suggest, is very important as a foundation for understanding where in the landscape Russell II applies, what parts of the landscape we're trying to assess with Russell II, and where it does not apply. Now we've got 52%, 55% of y'all have participated. And I'm seeing most of you having the right answer. So let's go over this. And okay, this is correct. Rills form on side slopes where lower energy sheet flow of runoff occurs. Meanwhile, gullies form in swales or drainage ways where higher energy concentrated flow of runoff occurs, right? The idea that there are different forms of water erosion and where they occur depends on the shape of the landform, right? So it also follows that B is correct, because we know that on side slopes, lower energy sheet flow of runoff does not have the energy to do a lot of soil detachment. The primary cause of soil detachment is going to be raindrop impacts, right, on those side slopes where rills tend to occur. Meanwhile, in the where you have gullies, that's usually where we have concentrated flow, higher energy water that's going to actually do the detachment, right? The runoff in those swales is going to do the detachment. This is also correct. Rills don't necessarily reappear in the same place year after year, but gullies do, because they're a factor really of the landform, right? And it makes gullies easier to recognize and address over time. And by the way, you know, that's one of the reasons we use Russell II to help us identify areas subject to sheet and rill erosion, because rills don't come back in the same place year after year. And so we need a tool. Meanwhile, gullies easier to recognize, and Russell 2, so happens, doesn't apply. This is wrong. D is wrong, which means that E is the correct answer, right? All of the above are true except for D. Rills are always shallow and can be erased with tillage. That's usually true. When they get crazy big, it can be as deep as gullies, but gullies are not always deep. Ephemeral gullies can be erased with tillage. So we had very good, you guys got almost all of you got the answers right. Good job. Just show you a couple pictures to remind you what we're talking about here. Here is sheet and rill erosion in a rainfall simulator tray, and you see we have a removal of a sheet of soil from this area, and it's deposited down here. If it weren't for these rocks and pebbles up here standing out on their own, we wouldn't have really, and we hadn't watched it happen in the rainfall simulator, we wouldn't really realize that soil had been moved. And that's the insidious nature of sheet erosion, hard to recognize. Now, when we get on a side slope like this, which is where sheet and rill erosion occurs, as we get more sheet flow, the water tends to concentrate in microtopography, and based on the microtopography, and we get these parallel rills, okay? But I think the best way to think about it is still the primary cause of detachment on this, in all these forms of erosion, is raindrop impact, okay? Because if those raindrops were not pounding the bare soil and causing detachment in the first place, just sheet flow alone is generally not enough to detach fine particles from their matrix, right? And start moving them. So that's the idea. Meanwhile, when we have concentrated flow, right, the landform, we have these side slopes over here, we have sheet and rill erosion, but you can see the landform concentrates water, and now we have enough energy in that water to start doing cutting and detachment. And this is going to be important for applicability of Russell 2. Where does Russell 2 apply in the landscape? So here's an example. Again, I showed this picture before in Pennsylvania, right? Obviously, there was some kind of erosion issue here. It's November 2nd, right? So they fixed this after a big storm. Look at that. February 26th, okay? Gully keeps coming back in the same place, right? And this is obviously a shallow gully. It's an ephemeral gully. We can erase it with tillage, but it's going to keep coming back in the same place. And Russell 2 is not designed to assess this. But luckily, this is easier to see with your eyes than the erosion that's happening on these side slopes. This is where Russell 2 applies. Okay, so this is just a little review. And finally, to remember that gullies, can get very deep. This is a classic, not an ephemeral gully. You're not going to erase this with one tillage pass. And these gullies can also sometimes just be on field edges here in Virginia, where we get what I call a blowout, water just pouring over the edge of the field, or maybe a little too close to the drop off into the woods in terms of where we're farming, and the whole edge of the field sloughs off. So, and starts cutting back and eating into the field. This is also a form of concentrated flow erosion. All right, so thank you for letting me warm you up with that. So now we're ready to jump into our first lesson for today, new material, and that is assessing sheet and rill erosion. I'm going to talk about the logic, history, and relevance of the fundamental universal soil loss equation formula.